Our last topic of the unit is called projectile motion. When we talk about projectile motion, we mean the motion of something that travels through the air under the influence of just gravity. A projectile is something that moves through the air under the influence of just gravity. We're studying the motion of that projectile over the next couple of days. Now, normally when you see a projectile, you see it launched like this, launched at an angle. Maybe it goes up like this, and it goes back down like this. That's not the only kind of projectile that you can have. Okay, if I throw a pen straight up into the air, that's a projectile. Okay, or if I drop a pen from the edge of a building, that's a projectile. But usually we're dealing with something like this, okay, where it's got an arc like this. Does anybody know what shape this would be by any chance? It's a parabola. Yeah, it is. Who said parabola? Good. It is a parabola. And you're going to see why a little bit later. You're going to see why this is a parabola. What I want you to recognize as we analyze this motion, the motion of this football or soccer ball or whatever it is that's moving through the air like this in a parabolic path, is that it has two components of motion. It has an x component. It's moving to the right, but at the same time it's moving to the right, it's either moving up or it's moving down. So it's got two components, right? Whenever we have two components to motion, we have to break it up into x and y components. Does that make sense? So we do have to break this up into x and y components. Now, the x component is the easier of the two to analyze. Why? Well, because the x component doesn't involve any forces acting. We said a projectile is under as an object that's moving through the air under the influence of just gravity. Gravity doesn't act horizontally. Gravity acts down. So that downward force of gravity doesn't affect the horizontal motion. Horizontally, this projectile moves at a constant velocity. The horizontal motion, if it's this much right here, then it's this much, then it's this much, then it's this much, then it's this much. You can see the value isn't changing. Does that make sense? Horizontally, it's not speeding up or slowing down. Clearly, the projectile is changing speed, but horizontally, it's not changing speed. Therefore, we'll describe the x component by this equation. V is equal to delta d over delta t. The x component is a group A problem because it's not changing velocity. But the y component is changing velocity. If we said this is the initial y component, as it goes up, the y component decreases, right? Because of gravity. So if you throw a pen up into the air, it slows down. What happens when it reaches the peak? It actually stops vertically, not horizontally. It keeps going horizontally at a constant speed. But vertically, it stops. And then what happens is it starts coming back down. It speeds up again, right? Make sense? Now, we can describe the y component by any of the group B equations because it's a group B problem. It's accelerating, right? But the one that I'm going to suggest to you to try first, because it usually works, is this one. D is equal to VIT plus 1/2 AT squared. You remember that, right? It's been over a week now since we've used that, but you remember that. D is equal to VIT plus 1/2 AT squared. Now, somebody, Ella, I think it was, told me this was a parabola. Ella, do you remember the equation? How many people have done parabolas in math class? Okay, some of you haven't. So if you haven't, don't worry. You're not going to be tested on that, okay? Ella, do you remember the equation for a parabola?
Is it like
I'm not sure what you're saying there. Say it again. Good, Ella. The equation for a parabola is y is equal to ax squared plus bx plus c. You recognize that, everyone? Those of you who have done polynomials in math class? Now, if we were to change the order of this equation that we use, d is equal to VIT plus 1 half AT squared, look at what would happen. We get d is equal to 1 half AT squared plus VIT. Like this is the equation for a parabola, right? Why is this the best equation to try using? Because it describes beautifully the path of this projectile. If the path of the projectile is a parabola, then why not use the equation for a parabola to describe it? So for the horizontal component, v is equal to delta d over delta t. For the vertical component, let's use d is equal to VIT plus 1 half AT squared.